All right, let's dive right in. Today, we're going to talk about something huge, a fascinating new theory of gravity that suggests our entire understanding of the cosmos, well, it might be due for a major rewrite.
For decades, we've had this story that most of the universe is made of this mysterious, invisible stuff, dark matter and dark energy. But what if that whole story is wrong? What if we've been on a wild goose chase for something that was never actually there?
Okay, so to really get why we might even need a new theory, we have to start with the man himself, Albert Einstein, and his absolute masterpiece, general relativity.
For over a century now, general relativity has been the absolute cornerstone of modern physics. Seriously, it has passed every single test we could throw at it, predicting how starlight bends, the existence of black holes, even gravitational waves. I mean, it is a masterpiece, no question.
But here's the thing. When we zoom way out to the scale of entire galaxies, the cosmos itself, the masterpiece starts to, show some cracks. Two massive puzzles just pop up. First, galaxies are spinning so incredibly fast that they should be flying apart. And second, the universe's expansion isn't slowing down like you'd expect. It's actually speeding up.
So, to make Einstein's math work with what we're actually seeing out there, physicists had to kind of add a couple of things in. They proposed that about 27% of the universe is dark matter, giving that extra gravitational pull to hold galaxies together. And then another 68% is dark energy, pushing everything apart. Together, that's 95% of everything, and it's totally invisible and, so far, completely undetectable.
And this is the real kicker. The question this new paper asks is, what if the problem isn't that the universe is packed with weird, invisible stuff? What if the problem is with our theory of gravity itself?
All right, so how do we fix this? Well, this new idea basically goes back to square one and rewrites the fundamental rules of gravity from the ground up.
Okay, think about it like this. Einstein's theory basically starts with a map that's already drawn. This map is the fabric of space-time, what physicists call the metric, but let's just call it the map. It defines all the distances, all the curves. The theory then just tells us how planets and stars follow the roads on that map.
Now, this new theory, it completely flips that script. It doesn't start with a map. It starts with the rules for how you move, what's called the affine connection. Think of it as having a compass and a rule book that tells you how to draw a straight line or make a turn at any given point. And from those simple local rules, the entire grand map of space-time just emerges. It's a really profound shift.
And here's what's so cool about the math behind this. The theory is built on something called the squared field strength, which just so happens to be the same kind of mathematical structure we use for the other fundamental forces, like electromagnetism. For a physicist, that's like a huge neon sign saying, hey, you might be onto something here.
Okay, that's all great, but here's the billion-dollar question. Does this actually get rid of the need for dark matter and dark energy?
This is where it all comes together so beautifully. The theory shows that Einstein's equations aren't wrong. They're just incomplete. They're an approximation. When you work through the math, you get Einstein's theory back, but with two little extra bits tacked on. Two geometric corrections that only really matter on huge cosmic scales. And get this, these two corrections line up perfectly with our two biggest problems. One is a global correction that works on the scale of the whole universe, and it acts just like dark energy. The other is a local correction that works on the scale of galaxies, and it mimics the effects of dark matter. It's just so neat. So let's take that first one. The global correction term just naturally makes the universe's expansion speed up. It just falls right out of the math. You don't have to invent some mysterious energy pushing things apart. It's just a feature of geometry itself in this more complete theory.
Okay, so what about dark matter? The local correction changes how gravity works inside a galaxy. It adds this, let's call it a boost to gravity, what physicists call a Euclid potential. What that means is it strengthens gravity over those huge galactic distances, right where we needed dark matter to be, and then it fades out.
And this, right here, is the big aha moment. Standard gravity says stars way out on the edge of a galaxy should be slowing down, but when we look, we see their speeds stay flat. Well, guess what? This new theory, with its geometric boost, predicts that flat curve exactly. And it does it using only the stars and gas we can actually see.
And we're not just talking in hypotheticals here. This actually works for real galaxies, like the Milky Way. The theory introduces a specific, measurable distance where gravity starts playing by these new rules.
For us, that's about 0.74 kiloparsecs, or roughly 2,400 light-years. That's a concrete prediction we can test.
But wait, there's more. Because solving the dark universe might just be the bonus prize. This theory also points us toward the holy grail of physics.
You know, the biggest, hairiest problem in physics is trying to unite gravity with quantum mechanics. For all its greatness, Einstein's theory is notoriously impossible to work with on the quantum level. Well, this new theory looks like it was born to do just that.
So you can really see the difference here. General relativity starts with the map. The new theory starts with the rules. And that simple shift, plus its mathematical structure, makes gravity look a whole lot more like the other forces of nature, which we already know how to handle with quantum mechanics. It opens up a whole new pathway.
So let's boil this all down. What's the takeaway? First, dark matter and dark energy might not be stuff at all. They could just be ghosts in the machine, illusions created by a theory of gravity that was missing a few pieces. This new model seems to do everything Einstein's theory does, plus solve the big puzzles, and it gives us a fresh shot at a quantum theory of gravity.
I'm going to leave you with this powerful line right from the paper's conclusion. Now look, this is a bold claim, and this idea has a long road of testing ahead of it, but it leaves us with this incredible thought. What if the dark universe isn't dark at all? What if we've just been looking at it with the wrong set of eyes?